Good evening, students. How are you? I'm Dr. Uqba Rafat. Welcome to the next lecture on the topic gamma and beta function. आज हम कुछ functions, special functions के बारे में पढ़ेंगे, which we so called gamma and beta functions. तो और इनकी प्रॉपर्टीज पढ़ेंगे और देखेंगे कि इनका कहाँ कहाँ किस तरह से यूज किया जा सकता है. So without any delay, let's start with gamma function. Gamma function. Gamma function. So gamma function we define as follows. We define इंटीग्रेशन ऑफ 0 to infinity. हमें एक फंक्शन को इंटीग्रेट करना है 0 to infinity. अगर वो कुछ इस तरह से है e to the power minus x, where x is the variable, and x to the power n minus 1 dx. Okay, where n is positive, where n is positive, n हमारा पॉजिटिव है. तो इस फंक्शन का इंटीग्रेशन हम इसको डिफाइन कर रहे हैं कि ये गामा एन है, गामा एन. ओके, तो दिस इज अवर डेफिनेशन ऑफ गामा फंक्शन. इसके बेस पे हम देखते हैं व्हाट इज द वैल्यू ऑफ, क्वेश्चन हमसे पूछा जाता है व्हाट इज द वैल्यू ऑफ, व्हाट इज द वैल्यू ऑफ गामा 1. This is question. We observe that the value of the gamma 1 is 1 only. बट इससे कैसे हम सॉल्व करेंगे देखेंगे. तो यहाँ पर हमने n की जगह पुटिंग n इक्वल्स टू 1 लेफ्ट हैंड साइड, इसमें हम लेफ्ट हैंड साइड में 1 पुट कर रहे हैं. 0 to infinity e to the power minus x, x to the power 1 minus 1. बिकॉज n हमारा पॉजिटिव है तो हम 1 पुट कर सकते हैं यहाँ पर dx. So after solving this, we get 0 to infinity e to the power minus x, x to the power 0, which is 1. ये 1 हो गया हमारा dx. तो बेसिकली हमारे पास बचता है 0 to infinity e to the power minus x dx. So the integration of e to the power minus x is minus e to the power minus x. और लिमिट क्या है हमारे पास, लिमिट है 0 to infinity. तो लिमिट पुट हम करेंगे तो क्या बन जाएगा, e to the power minus infinity and e to the power 0. ठीक है, e to the power 0. e to the power minus infinity को हम लिख सकते हैं 1 upon e to the power infinity, और e to the power infinity को हम infinity रखते हैं. तो 1 upon infinity ये 0 बन जाएगा. So this term is will become 0 and minus minus plus, this is e to the power 0, which is 1. So the value of this integration, this integrand is 1, hence this must be equals to gamma n, and where n equals to 1. So the value of gamma 1 is 1 itself. तो यहाँ पर हमने इसको प्रूफ किया है कि वैल्यू ऑफ गामा 1 इज 1 होती है. सिमिलरली हम कुछ प्रॉपर्टीज यहाँ पर लिख रहे हैं जिसको आप वेरीफाई कर सकते हैं विद दिस डेफिनेशन. प्रॉपर्टीज, फर्स्ट ऑफ ऑल, नंबर 1, the value of gamma n plus 1 is redefined as n gamma n. Similarly, the second one is, if we define gamma n plus 1, so this is nothing n factorial or factorial n. So we know about how to open the factorial, and gamma function is reduced in factorial. The third property is gamma function is, the value of gamma 1 by 2 is root pi. This is very important, and we use this property of gamma very frequently. This is important. So if we ask the value of gamma 3 by 2, so we can write 1 by 2 gamma 1 by 2 by this property. n gamma n. Okay, so the value of gamma 1 by 2 is root pi, so this is 1 by 2 root pi, so the value is root pi by 2. Okay, similarly we can solve the other values of gamma in the similar manner. So this is the question. The value of gamma 1, we can prove easily that the value of gamma 1 is 1, and these are the properties. From here we can also observe that the value of gamma n plus 1 is, if we put n equals to 0, so this is 0 plus 1, this is gamma 1, and this is 0 factorial, so value of 0 factorial is 1. But with the help of this integration, we can also prove the value of gamma 1 is 1. So let's try some more examples on this function. Now we have to evaluate the value of this integration. Basically, now this is the part of application of gamma function. Application of gamma function. Application of gamma function. So these types of integrations we can solve with the help of gamma function if we remember the properties and the definition of gamma function. So these type of integration are very basic for us. Let's define here what is gamma function. 0 to infinity, so we get here 0 to infinity, जो आपको हिंट देगा कि हमें गामा फंक्शन से सॉल्व करना है. ओके, अगर ये कुछ और लिमिट होती तो हम इसमें गामा फंक्शन नहीं यूज़ कर पाएंगे. तो हमें 0 टू इन्फिनिटी से याद रखना है कि कुछ ना कुछ गामा फंक्शन से सॉल्व होगा. एंड दिस इज e टू द पावर समथिंग, दैट्स मीन e टू द पावर वी हैव minus x and x to the power n minus 1 dx, which we defined as gamma n previously. ओके, अब इसकी शक्ल जो है कुछ हमें इस तरह से बना देनी है. तो हम कुछ सॉल्व करते हैं ना. पुटिंग जैसे यहाँ पर हमने रूट एक्स को टी कंसिडर कर लिया है. एक नया वेरिएबल हमने कंसिडर कर लिया है, रूट एक्स इक्वल्स टू टी. अगर हम लिमिट की बात करें तो 0 पुट करेंगे तो 0, इन्फिनिटी पुट करेंगे तो इन्फिनिटी. तो लिमिट विल नॉट चेंज हियर, तो लिमिट तो यही रहेगी. और इसको अगर हम डिफ्रेंशिएट करेंगे स्क्वायरिंग बोथ साइड करके, दिस विल बिकम x इक्वल्स टू टी स्क्वायर, and this will become dx equals to 2 times t dt. Okay, so the value of dx is here 2 times t dt. और हमारा ये जो फंक्शन इस तरह से चेंज हो जाएगा 0 टू इन्फिनिटी. अगर हम इसको लिख पाए x टू रूट x की पावर, दिस इज x टू द पावर 1 by 4, so this will this root x की पावर 1 by 2, e to the power minus root x and dx. Now replace everything. Limit will not change here, तो लिमिट तो चेंज नहीं होगी. 0 टू इन्फिनिटी हमारे पास रहेगा. रूट एक्स की जगह हम टी पुट कर सकते हैं. दिस इज टी 1 by 2 e to the power minus this is e to the power minus t, and in the place of dx we put 2 times t dt. 2 हमारे पास इंटीग्रेशन से बाहर आ जाएगा. 0 टू इन्फिनिटी e to the power 1 by 2 e to the power minus t and t dt. t की पावर 1 by 2 and t की पावर 1, ये हमारा कंबाइन होके हो जाएगा 0 टू इन्फिनिटी e to the power 3 by 2 and e to the power minus t dt. इसको हम लिख सकते हैं टू इंटीग्रेशन ऑफ 0 टू इन्फिनिटी e टू द पावर माइनस टी हम पहले लिख रहे हैं क्योंकि यहाँ पर ऐसे इस तरह से फॉर्म है. अब t टू द पावर n माइनस 1 है, तो हम इसको लिख सकते हैं t टू द पावर 5 by 2 minus 1, which is equal to 3 by 2. From here we get the value of n. The value of n by comparing this integration by this, So we get n equals to 5 by 2. So this value is nothing, but equals to 2 times, and this value is become gamma 5 by 2. Gamma 5 by 2. Now using some properties of gamma here, 2 times gamma 5 by 2, which we rewrite as 2 times gamma 3 by 2, 3 by 2. Gamma n plus 1, gamma n plus 1 is gamma n into n. Further we write 3 by 2 into 1 by 2 into gamma 1 by 2. इसको हम ओपन करते जाएंगे इस तरह से, तो ये कैंसिल आउट हो जाएगा और यहाँ पर हमारे पास वैल्यू बचेगी 3 by 2 एंड द वैल्यू ऑफ गामा 1 by 2 हमने पीछे देखा, इसकी वैल्यू होती है √π. सो ये हमारा रिक्वायर्ड आंसर हो जाएगा. So the value of this is 3 times √π by 2. Okay, so this will become simple by using gamma function here. So with the help of the gamma function, so integration of this type, integration of 0 to 1 x to the power m, यहाँ पर इंटीग्रेशन 0 to 1 हो गया है. इसको आप प्रूफ करने की कोशिश करिएगा. प्रूफ थोड़ा सा मैं हिंट दे दूंगा और तो आपको प्रूफ करना है x to the power m log x to the power n dx is nothing but minus 1 to the power n upon m plus 1 to the power n plus 1, and this is gamma n plus 1. Okay, so this will you have to prove. मैं थोड़ा सा हिंट यहाँ पर लिख रहा हूँ. हिंट, आपको इसको प्रूफ करना है log x इक्वल्स टू पुट करके लेट log x इक्वल्स टू माइनस टी. इसको लेट करेंगे तो यहाँ पर x इक्वल्स टू e टू द पावर माइनस टी हो जाएगा और यहाँ पे रिप्लेसमेंट करके आप इसको प्रूफ कर सकते हैं विद द हेल्प ऑफ आवर गामा फंक्शन. व्हाट इज दैट? 0 टू इन्फिनिटी. लिमिट भी चेंज हो जाएगी यहाँ पर. जब हम log 0 की वैल्यू पुट करेंगे तो log 1 की वैल्यू पुट करेंगे तो इंटीग्रेशन log 1 इज 0 और ये हमारी लिमिट्स भी चेंज हो जाएंगी. ये हो जाएगा e टू द पावर माइनस एक्स टू द पावर n माइनस 1 की फॉर्म में और dx इक्वल्स टू गामा n. इसकी हेल्प से हम इसको प्रूफ कर पाएंगे. इस पे हम एक क्वेश्चन करते हैं. क्वेश्चन नंबर 1 इस प्रॉपर्टी पे इंटीग्रेशन ऑफ 0 टू 1 x टू द पावर x log x to the power 4 dx. So this is important. When we have integration 0 to 1 x to the power something and log x to the power something, then we can use this formula here. So we notice that we can write it 0 to 1 x to the power 4 log x to the power 4. So the value of m and n equals to m equals to n equals to 4 here. So right hand side is minus 1 to the power n on m plus 1 to the power n plus 1 equals to into gamma n plus 1. So this will become minus 1 to the power 4, which is 1. M plus 1 means 5 to the power 5 into gamma 5. So after solving this we get 5 into gamma 4 upon 5 to the power 5. So we cancel out this. So this will become gamma 4 upon 5 to the power 4. This will be the answer. So by using this basic property we can easily solve this type of integration. So remember this form. This is one form, 0 to 1 x to the power m log x to the power n dx, which can be write in this formula. This is formula for this integration. Okay, so class, next we come to the beta function. Here, after doing some properties and questions on the gamma function, now we are familiar to the gamma function to some level. Now what is beta function? A beta function is defined as 0 to 1. We have to remember, so we have to take this integration in this interval only, 0 to 1. So this is x to the power l minus 1 and 1 minus x to the power m minus 1. So this type of x to the power something, obviously this is the form of l minus 1, and 1 minus x to the power m minus 1. This we define as beta of l comma m, where l is positive and m is positive. So here we call this is beta function, in the form of this is beta function, beta of l m. So if the integration of this is beta lm, then we have some properties which we relate to our beta function to gamma function. So relation between beta function and gamma function. So this is important. So beta function of l comma m, which is defined as this is nothing is gamma l into gamma m upon gamma l plus m. Okay, so this can be formula for to relate the beta and the gamma function. Now let's do some example on this type of functions, and be reduced into gamma function when solving these type of integrations. So students, we have this question: integration 0 to 1 x to the power 4 1 minus root x to the power whole to the power 5 dx. So with the help of beta function, we define as beta function like this: integration 0 to 1 x to the power l minus 1 1 minus x to the power m minus 1. This is dx is called beta lm, and beta lm is defined as gamma l into gamma m upon gamma l plus m. Okay, so we reduced this integration in this form, and by using these properties we can evaluate this integration. So here we have x to the power 4 1 minus root x to the power 5. So this is root x, not x, so we can't use it directly. We can reduce in this form. So root x, let root x is over t. Now suppose this is t, so first of all we have to check the limits. So root 0 is 0 and root 1 is 1, so the limit of the integration remains same, and the value of x is t square, and the value of dx is 2 times t dt. Okay, so this 2t dt. Now check this, देखते हैं इसको कैसे रिड्यूस करते हैं. इंटीग्रेशन की लिमिट मैंने आपको बता दी है कि 0 to 1 रहेगी. x to the power 4 है और x की वैल्यू t स्क्वायर है, तो ये हो जाएगा t स्क्वायर टू द पावर 4, एंड 1 माइनस रूट x की वैल्यू t है, तो ये हो जाएगा हमारे पास 1 माइनस टी टू द पावर 5, एंड dx की वैल्यू है 2 टाइम्स विच वी राइट outside the integration t dt. Okay, now this will become 2 times 0 to 1 t to the power 4 to the 8, and this is t to the power 1, t to the power 9, 1 minus t to the power 5. Or we can write 0 to 1, t to the power, this is obviously dt, 10 minus 1, 1 minus t to the power 6 minus 1. So the value of L is here 10, the value of M is 6. So this will become beta 10 comma 6. Now we are only find the value of beta 10 comma 6 here. The value of beta 10 comma 6. So beta 10 comma 6 is gamma 10 into gamma 6 upon gamma 10 plus 6, which is 10 plus 6. Sorry, this is 6. So gamma 10, we use the property gamma n plus 1 is factorial n. So we use here 9 factorial. Okay, here factorial, and here 10 plus 6 is 16, this here 15 factorial. So we can write it 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2, 9 factorial, and 6 factorial is 6 into 5 into 4 into 3 into 2. Okay, and 15 factorial is 15, 14, 13, 12, 11, 10, and this will become 9 factorial. So we can cancel out this 9 factorial. Okay, here is 6 factorial. 6 means 6 1 the 6, 6 2 the, and this 5 1 the 5, 5 2 the, and this is 2 and 2. So this will become 2 2 the, 2 7 the. So after solving, we get some result, but I can help you that this will reduced in this form. Okay, with the help of the beta and gamma function, we can solve this type of integrations. You can solve this further by using simple multiplication. Okay, class. So this will become interesting. Now we can also see some different forms of beta function, formations of different forms. So students, next we have very important formula, and we have to prove that prove that this is very important and very interesting also. We can use very frequently in our questions. So this is integration of 0 to pi by 2 sine to the power p theta cos to the power p theta d theta, which is nothing but gamma of p plus 1 by 2 gamma of q plus 1 to the, this is 2 times gamma p plus 1, sorry, p plus q plus 2 by 2. So this is this. हमें इसको प्रूव करना है basically with the help of beta and gamma function. So what is the definition of, इसको प्रूव करेंगे. What is the definition of beta function? Beta function is, if we write in the form of m and n, so this is 0 to 1 x to the power m minus 1, and this is 1 minus x to the power n minus 1 dx. Okay, next we can write this gamma m into gamma n gamma m plus n. Now suppose this is equation number A. This is very important. Basically, this is our formula, relation between beta and gamma function. So this can write this. Now in this integration, let us suppose let x equals to sine square theta. This is our supposition. We can replace x by sine square theta. Now while doing differentiation, we get dx equals to 2 sine theta, and the sine theta is cos theta d theta. Okay, and the limit is when we put 0, sine theta sine square theta is 0, and if we put 1, then sine theta is root 1. This is 1, and sine theta is pi by 2. So the limit goes to 0 to pi by 2, and the integration will become 0 to pi by 2, 0 to pi by 2, and x to the power m minus 1. So x is sine square theta to the power m minus 1, and 1 minus x is 1 minus sine square theta. This is sine square theta, 1 minus x sine square theta n minus 1, and dx is 2 times sine theta cos theta, and this is d theta. Okay, now when solving this 0 to pi by 2, this is sine to the power 2m minus 2 theta, and this will become cos, this is cos square, cos to the power n minus 2, 2n minus 2. This is cos square theta, so this will become this, and this is 2 times sine theta cos theta d theta. So here we have, write it here, sine to the 2m minus 2 theta cos to the power 2n minus 2 theta, and here 2 sine theta. So here 1 power, here we can add this, so this will become 0 to pi by 2 sine 2m minus 1 theta, obviously, and cos 2n minus 1 theta, and this is 2. You can write 2 outside the integration, and this is d theta. Okay, class. So now we can change our light by putting 2m minus 1 by p and 2m minus 1 by q. So the value of m is, here we can see p plus 1 by 2, and the value of n is q plus 1. When you put this value here, the value of m in the equation 1, so we get from equation 1, we get a, from equation a we get gamma e plus 1 by 2 gamma q plus 1 by 2, and here 2 is goes to here 2 times gamma. The value of m is e plus 1 by 2 plus q plus 1 by 2. So here can rewrite e plus 1 by 2, q plus 1 by 2, and this is 2 times p plus 1 plus q plus 1 by 2. So this is this. So with the help of beta and a gamma function, we can write 0 to pi by 2 sine to the power p theta cos to the power p theta d theta is this. So we use this formula directly in our questions. Okay, so let's do some examples. So next we have one example on the basis of the property of beta function. So earlier we have seen that 0 to pi by 2 sine to the power p theta and cos to the power p theta d theta is nothing but gamma of p plus 1 by 2, gamma of q plus 1 by 2 and 2 times gamma p plus q plus 2 by 2. So with the help of this, let's consider one example. 0 to pi by 2 under root of cot theta d theta. So notice that the limit of the integration is 0 to pi by 2. हमें ये चेक करना है कि लिमिट हमारी 0 to pi by 2 ही होनी चाहिए. ठीक है, इस फॉर्म में हम इसको रिड्यूस कर लेंगे, मगर अगर हमारी लिमिट ही नहीं हुई तो हम ये फॉर्म नहीं लगा सकते. ओके, अगर इंटीग्रेशन इस टाइप से आ रहा है जिसमें लिमिट 0 to pi by 2 हो और कुछ फंक्शन हो जो हम इस फॉर्म में रिड्यूस कर सकते हैं, तो इसको कैसे रिड्यूस करेंगे इस फॉर्म में? लेट्स चेक. 0 to pi by 2 we can write cot theta is cos theta upon sin theta, obviously d theta. So this will become 0 to pi by 2 cos to the power 1 by 2 theta and sin to the power 1 by 2 theta d theta. And this is 0 to pi by 2 sin to the power minus 1 by 2 theta cos to the power 1 by 2 theta d theta. So now this is now in the form of this. So the value of p here is minus 1 by 2 and the value of q is 1 by 2. So right hand side, from right hand side we can write gamma, this is p plus 1, that is minus 1 by 2 plus 1 by 2, gamma 1 by 2 plus 1 by 2, and this is 2 times gamma minus 1 by 2 plus 1 by 2 plus 2 by 2. Okay, now solve this. This is gamma, this is 1 by 2 and this is 1 by 4 and this is gamma 3 by 4 over this will become 2 gamma 1. The value of gamma 1 is 1, so this will become gamma 1 by 4 gamma 3 by 4, this is 1 by 2. So this is the answer. Very simple. So the integration of 0 to pi by 2 root cot theta d theta is this. Okay,